What's up everyone? So on this video we are going to talk about our first scenario, which is when you have normalized data in your cache and the mutation that you perform returns the same type of object. But first, let me disclose something to you. In the app you might encounter the term correct type names. This is actually referring to normalizable data. It means that the type name of the objects returned by the server actually represents the type of the object that is going to be consumed by the application. This may sound confusing at first, but it just means that if we are manipulating coloring books, for instance, the server actually provides us with coloring books and not some other abstract type. So if we move on to the application, okay, so here we have our application. It works by creating a new instance of Apollo client containing the desired configuration every time we switch. For the user, they all work the same way. The difference is really under the hood. So when we fetch data from our server, you are going to notice on the right-hand side the current state of our cache data. And here are our two mutations, favorite and delete. If we simply delete all books, they will all be gone. Now, if we favorite them before deleting, you'll notice that Apollo keeps the data in the cache. This happens because in this scenario, the return from the favorite mutation actually contains data that Apollo can link to objects in our cache. In this case, title and type. So as you can see, Apollo automatically stores a reference to the updated object in the mutation return. That's why if we delete a favorited book in this scenario, Apollo only removes the reference from the root query, but it still keeps the data around because as there is still some reference to that object hanging around, it can't be sure that that data won't be needed somewhere else in our application. To get around this, we would need to use cache eviction. Now let's go back to our presentation. First, let's talk about our server. This is our data. As you can see, we have a single array containing all our books. Our server provides us with a single query which returns all our data at once. And of course, the two mutations responsible for favoriting and deleting books. As you can see, the delete book mutation only returns a boolean, which emulates a successful deletion. More importantly, the favorite book mutation returns the object's key field, title in this case, and its type, and of course, the updated field. Now let's see how to interact with this on the client side. At the entry point of our application, we can fetch the available data from our server, and then this data hydrates our cache. From this point, all the interactions between the components and the data are going to be interfaced by the cache. This gives us a tremendous amount of control over when the data is actually going to be fetched from the server. But for this to happen, we have to provide our cache with its own client-driven configuration. So we define the queries that are going to be used by the components to interact with the cache. And of course, we have to tell it what to do when a component queries for these fields. Because remember, these fields are not on the server. For this, we can use a read function, which gets fired every time these fields are queried, anywhere in our application. The read field function is used as a complement because it is more flexible than the read function. Using read field, we can read data that is stored elsewhere in our cache, rather than just the field that is currently being read. In this case, we are going to read the schoolbooks field from the root query, which contains all the data returned from the server. Then, we filter only the desired objects and return only the references to them. When we return the references, our client-side query is able to interact with the data through GraphQL syntax, just like we do with the server. And that's it for this video. Let me know in the comments if you have any question, and I'll see you in the next one.